6.2, if you still remember, section 6.2 is about volumes as applications of integrals. We have spent the whole class of the previous class, of course, talking about this issue. As you can see here in this two photos, we have here sigma phase integral. I think what you did understand in the previous class that the sigma is approximation. We can use the sigma to approximate the volumes. But to find them exactly, we need to find the limit of that sigma, the limit of the Riemann sum, which will be, of course, in terms of integrals. These are the main objectives that we need to achieve in 6.2. I think we have already achieved the first two objectives. Do you know, ya shabab, what we mean by a solid, by a cross-section, and how to find the cross-section area? And also how to find volumes by slicing. We already, I think, achieved these objectives in the previous class. Today, inshallah, we will see together what are the solid of revolutions and how to find their volumes by disk method and by the washer method. Let me just go quickly over what we did in the previous class. I think we need to stop this. Yes, just I'd like to go quickly over what we have done in the previous class to refresh your memory. So we started by recalling the well-known formula for the well-known solids. Then we defined the cross-section, what we mean by cross-section, and what is AX here. AX is the area of the cross-section. And of course, we have shown you that the volume is just the integral of the area of the cross-section. If the cross-section perpendicular to the x-axis, then you will integrate with respect to x. If it is perpendicular to the y-axis, you will integrate with respect to y. And we have showed also, we have used that one to show the volume of the cylinder, the volume of the sphere, the volume of a pyramid, and also a solid with a circular base and triangle cross sections. We have solved also this on the exam question. I think we need to start today from here, from the solids of revolutions. I think you know, Shabab, what we mean by revolution here. Revolution means rotation. So if you have a region like this, so this region is bounded by the curve. Let's say this curve is the curve of the function y equals f of x, from 0 to whatever, to b, for example. Now, if we rotate this region about the x-axis, imagine that we have this region and we rotate it like this. We will have the following solid if we did that. Now, the distance from here to here, the distance from the upper cover, you remember the y top and y bottom from 6.1. Here we have the upper curve and the lower curve. Then the distance between them, the distance between the upper cover and the lower cover, we will call it R capital X, R of X. Here it is. This will be, when we have a revolution, a solid of revolution, when we rotate it, look at the solid that we will have. This is the solid that we will have if we rotate this. What you can think about, ya shabab, is if you make the cross section here, if the cross section, of course, the cross section here is perpendicular to the x-axis. What is the cross section in this case? Here it is. If you cut it, imagine that you cut it by a knife perpendicular to the x-axis. If you look at the cross section here, this is the cross section. Imagine that you cut it here. When you cut it into pieces, if you look at the piece that you'll have, you will watch a circle. Indeed, it is a circle with some thickness. There is a thickness here. When you have a circle with some thickness, we call it a disk. So this is a disk. It is very thin here. The distance here, the thickness is delta x. And of course, The radius here, the radius is the distance from the x-axis to the curve, which is Rx. And you know, Shabab, when you have a circular disc, what will be the area of the disc here? The area of the disc will be what? It will be by r squared. In our case, r squared is r of x all squared. So we know now what is the circular, the area of the cross section. You can think about it now, how to find the volume of this solid. You can think about it just that you have a cucumber and you want to find the volume. So you can approximate it by just finding the volume of one piece, and you can integrate it, approximate it to be the integral of the whole solid. So what is the solid of revolution? If you want to give it a definition, it is a solid obtained by revolving a region about a line. In our case, this line here is the x-axis. It could be the y-axis. It could be any another horizontal line or vertical line. As I said, Shabab, we have some thickness here, delta x. The area, of course, of the cross section. This is the area of the cross section, the area of this disk. It is by times the square of the radius. It is by r of x all squared. Why r of x, not r of y? Because here the cross section is perpendicular to the x-axis. We will see this always when we have a rotation about the x-axis or about any line parallel to the x-axis. Always we will integrate with respect to x. If it is the opposite, we will integrate with respect to y. And you remember, Shabab, what is the volume? The volume is just the integral from a to b for the area of the cross section. This is what we have learned from the previous class. So now in our case, just we will replace this ax by the area. So we have a formula here. So this is easier, Shabab. When you know what is the area of the cross section, just you need to find the radius here. So when we have a region revolved or rotated about the x-axis, then the volume, its volume will be just the integral from a to b by r squared dx. Just you need to find r of x. What is r of x? The distance from the upper cover to the lower cover, the distance from the upper point on the graph until the axis of the rotation, the radius of the cross section. This method is called طبعا the disk method because the cross section is a disk. I have here, ya Shabab, made the steps for you how to find the disk method. I think it is very clear. You need to sketch the region, not necessarily the solid. So you need to draw a line perpendicular to the rotation line. So if you have here, for example, let's talk about the x-axis or any line parallel to the x-axis. What you need to do, this is the region, this is the x-axis. Draw a line perpendicular to the x-axis. So it will be perpendicular to the rotation line. Secondly, find the formula for ax. The formula here is ready. Just you need to find r of x. To find ax, you need to find rx. Just multiply by that. Find the radius r of the disk. In the third step, of course, you need to find the limits of the integration. Usually they are from the beginning of the solid until the end of the solid. Then integrate. This is the formula now that we have. Let's take an example. Find the volume of the solid obtained by rotating about the y-axis. So it is important to start with realizing, it should be mentioned here. Yes, this is what you should realize at the beginning, that the axis of rotation is about the x-axis. We are going to integrate with respect to x. So this is very easy when you want to use the disk method. Now, for the region under this curve, y equals square root of x from 0 to 1. You know how to sketch this graph, Shabab. Step number 1, sketch. So this is y equals square root of x. And this is the axis of rotation. We mean here that the rotation will be about the x-axis. Now what we will do, we will draw a typical rectangle, or let me make it simply a line. It is not necessarily to be a triangle, just and you will draw a line, any line at any place here or here, whatever. Since you can draw it anywhere between 0 and 1, we will call it a variable x. So imagine that I draw that line here, or here, or wherever. So if you call it x, notice here that what will be the length of this line? What will be the distance from this point to this point? Who can tell me, Shabab? This will be the radius of the solid. If you revolve or rotate this region about the x-axis, this is what you are going to have. Look, this is a disk. Now, what is the radius of the disk? The radius of the disk will be this distance, which is exactly this line, or this line, whatever it is. It should be the same one. It depends on where you make the cross section. Okay, so let's make it just as we did before. So the radius here is this distance, and you know, ya shabab, here what is y here? طبعا here it is a vertical line. When you have a vertical line, x is fixed. X will be the same here or here or here or here. So x is fixed. What will be the difference? The difference from this point to this point, it will be the vertical distance. The vertical distance, it is the difference between the y coordinates. What is y here? At this point, what is y? It is square root of x. What is y here, ya shabab?
0.
Y equals 0. What is the distance from here to here? If this is 5 and this is 0, the distance will be 5 minus 0. It will be 5. So here, similarly, the distance, which is the radius here, it will be the radius of the disk. R of x here will be just the upper minus the lower. It will be the square root of x. So this is the radius of the disk. Just square it, multiply it by, integrate it. Integrating from where to where? So this is step number 1, we sketch. Step number 2, we did find the formula for the area of the cross section. In fact, we just find R of x and we square it after that. Now you need to integrate from where to where, Shabab? Look at your region here, this region. Start from where? From 0 up to where? Up to 1. It is given, by the way. This is very clear. So we will just integrate from 0 to 1. So the volume will be the integral of the area of the cross section. And the area of the cross section in our case, it is pi times the square root of x all squared. It is by x. What is this? It is just by r capital of x all squared. Yes, yeah, Nawaf.
Sorry for the interruption, Doctor, but what can we do if he didn't give us the limit of the integration?
You need to find them. You should be, we will see that in the next example, how to find the limits if they are not given. Of course, you should have a limits for the integral. And of course, ya shabab, the pi is a constant. You know how to integrate. I will not talk about the integration process. You should be able to do that. طبعا here, why you should, Shabab, mention the thickness. The thickness, is it delta x or delta y? If it is like this, it is delta x. The change is on x-axis. And this will tell you to integrate with respect to x. If the thickness of the disk is delta y, you will integrate with respect to y. This is an exercise. Find the volume of the solid generated by revolving the region, the same region that we have before, look. But here we have additional lines. We have y equals 1, x equals 4, and what is the axis of the rotation? We will rotate or revolve the region about the line y equals 1. So first of all, you should focus on this part. In the previous example, what was the axis of rotation, Shabab? It was y equal what? Y equals 0.
0.
Yes, now it is y equals 1. So both of them are horizontal. So this is good. We will integrate with respect to x. So first of all, we will sketch the region. So this is y equals square root of x, the same graph. But here we will draw the line y equals 1. So the region is between this curve and this curve. It is this region here. Now x equals 4. This is x equals 4. And these are 3. We have 3 graphs here. This graph, and this graph, and this graph. we have three graphs. We sketch them, this one, that one, that one. Now, this is the region that is enclosed by these three curves. Now, the axis of the rotation is y equals 1, this line. Again, the idea now is to imagine, you need يا شباب to, this is a must, you have to sketch this. It is important to sketch the region, but it is not important to sketch the solid. But of course, I'm showing you here the solid just to give you the whole picture, how it looks like. So now if you rotate this about this line, about y equals 1, this is what you are going to have. It is a disk. The cross section is a disk. Now your task is to find the radius of this disk. The radius of this disk will be the length of this line segment. This line is the radius, and this line, in fact, is just the distance from this point to this point. Again, at this point, y is equals to square root of x. At this point, y is 1. So the distance will be what, ya shabab? Square root of x minus 1. So this will be the radius of the disk. Now what you will do, you will just multiply it by and square it. And then you will integrate. From where to where? This is the question. You can see clearly, Shabab, if you sketch the graph, you will integrate up to 4 because it is clear from here that the x values, the maximum is 4. Here, this point, you need to find what is it. And you can see clearly you have y equals 1 and y equals square root of x. When you have y equals square root of x and y equals 1, when you equate them, you will have square root of x equals to 1, and this means that x is 1. So you will start from 1. I think this will answer your question in a way, partially, طبعا, but of course we will do it with more general curves. Next, you will integrate the area of the cross section. It is pi, and this is just r of x all squared. The square of the radius multiplied by pi. Now you need to expand here to find the integral, then continue. You know how to do that. Any question, Shabab?
Doctor,
Yes.
Rx equal radical x minus 1 because the graph is shifted to the right.
No. Who said that the graph is shifted to the right? What is the equation that says there is a shifting?
Because
No,
the solid
not
is
because-
not start from 0.
Not because of that. Who is talking?
Yes, Zaki.
Zaki. What is Rx? R capital. What is R capital? R in general. What is R capital here? What does it represent?
The distance from upper to the,
Lower.
yes,
It is the radius. Here it is. It is the radius of the disk. The radius of the disk will be the distance from the upper point here up to the axis of rotation. So now this is a vertical line. In the vertical line, x is the same, look, x is the same. But here, the vertical distance will be the distance from this point here. What is the y coordinate here? The y coordinate here is square root of x. What is the y coordinate here? It is 1. So it is just the square root of x minus 1. So it is not about shifting. Now, I can ask you now a question. This question, we will answer it in next section, in 6.3. What about if the axis of rotation here, we have the same region, this region. But the axis of rotation is not y equals 1. It is y equals 0, the x-axis. Is the cross-section will be a disk or not? When you rotate this region, about the, it will not be a disk. There will be a hole because of this space here. We have a space here in between. There is a space between the axis of rotation and the region. In that case, we will not have a disk. We will see that in 6.3, inshallah. Okay, now, what about if your graph is given as x a function of y, not y a function of x, and the axis of rotation is the y-axis, x equals 0. So it is a vertical line. In this case, you will do the same, but this time for y, you will integrate with respect to y. So in this case, you will have the radius as a function of y, r of y, not r of x. So it is, you will use the same method with x replaced by y. And the steps are quite similar. Okay. Now let's take an example. Find the volume of the solid obtained by rotating the region bounded by this curve. Y equals x cubed, y equals 8, and x equals 0. We have three curves. And the axis of rotation is the y-axis. So we have here x equals 0 is the axis of rotation. The axis of rotation is vertical line, the y-axis. So we will integrate with respect to y. We will see y, of course. Now, you need to do, as I said, you need to do a sketch for the region. It is important step. You have to do it. So this is the region, ya shabab, that we have. We have y equal x cubed. You know how to sketch the graph of y x cubed. Y equals 8. It is a horizontal line. X equals 0. X equals 0 is the y-axis. So these are the three graphs. One, this is x equal to 0. This is y equals to 8. And this is y equals to what? To x cubed. Now, this is the region that we want to work on. This is the region. The question is, this is 0, of course. Which axis that we are rotating about? It will be rotated about the y-axis. So this is the axis of rotation. So when you rotate it like this, look what you will have, how your solid looks like. So if you rotate this, if you rotate it like this is what you are going to have. Now, if you cut it, because here the axis of rotation is the y-axis, if you cut it horizontally, perpendicular, if your knife or your cross section is perpendicular to the x-axis, to the y-axis, in this case, what will be the disk? This will be the disk, the circular disk. Now, what will be the radius of this disk? Because the area will be just multiplied by the square of the radius. The radius will be the distance from the axis of rotation, from here, from this curve, from this point to this point, to the axis of rotation. This will be the disk. طبعا it is, as I said, shabab, you don't need to sketch this. If you did, it's okay, but no need. Now, how to find the distance from here to here? It is a horizontal line. When you have a horizontal line, shabab, y is the same. Y is fixed here or here or here. You have the same y. Where will be the change? The change will be on the x values. So x value is not the same here or there. So if you have here x is 5 and x here is 1, then the length will be 5 minus 1. It will be 4. Here, what is x here? You need to ask yourself, what is x right and what is x left? The same idea that we used when we were calculating the area. What is x right here? What is x here? X here, you need to solve this equation for what? For x. So it will be x equals what? The cubic root of y. So here it is. This is x equals cubic. What is x here, shabab? This is x here.
0.
X here is 0. So it will be this minus 0. Here we have cubic root of x. Here we have 0. So it will be, the distance here will be just the cubic root of x minus 0. And this will be of course, sorry, this cubic root of y, not of x. This will be r of y. So r of y, the radius of the disk, will be just cubic root of y. Square it, multiply it by pi, integrate. From where to where? You will integrate with respect to y, طبعا. With respect to y, because the line is vertical. You will integrate from where to where? Look at the y values. We have 2y here. So here we have, from this, we have y equals x equals the cubic root of y. And here we have x equals 0. So now if you equate them, it will be the cubic root of y equals to 0, y equals to 0. So one of the limits of the integral is 0. And what is the other one? It is here. It is clear from the graph, ya shabab. Look, y values start from where? From 0. And up to where? up to here. What is this value? It is 8. So here, be careful. These are y values, not x values. We will see also in the next section how to solve this if the axis of rotation, of course, is another line, like the x-axis or any other line that you can find. Any question, Shabab? So now, as we said, the area of the cross section, it will be just by the cubic root of y squared, which will be by 2 by y cubed. Just think about what is r capital here. What is the radius? We use, by the way, the r capital here because we need r small for something else in 6.3. So integrate by multiply by the square of the radius. And of course, after that, it will be just a matter of calculations. Any question, Shabab? Let's take I think I will skip this exercise. It is very clear and it is solved, by the way. Just let's check the idea. Find the volume between the y-axis, x equals 0, the curve x equals 2 over y. It is clearly you have x equals 0, x equals to y, and y between 1 and 4 about the y-axis. So here you will integrate with respect to y clearly. So now what you will do, you will sketch the region. This is x equals 2 over y, or it is the same, by the way, as as y over 2x. This is the reciprocal graph, if you remember. It is just like this. Okay, now the y-axis, this is the y-axis. Y between 1 and 4. This is the region. Now, again, you will find the radius. The radius is the distance from here to here. It is horizontal line, so it will be y value. So here, what is x right here? It is 2 over y. What is x here? X here is 0. So it will be 2 over y minus 0. 2 over y minus 0. You will square it, multiply it by, integrate it. From where to where? Y start from 1 up to where? Up to 4. It is given. dy. That's it. This is the integral. Is it clear? How to integrate if you have the region rotation about the vertical line. Find the volume of the solid generated by the region between the parabola. We have a parabola here. It is clearly x as a function of y. So it is clearly we will integrate with respect to y. It looks like this from the beginning, but let's make sure about that. And we have also another graph x equals 3 about the line x equals 3. So the line here, the axis of rotation, the line of rotation is a vertical line. So it is parallel to the x-axis. This is the x-axis, parallel to the y-axis. So now this is x equals 3. Now, where is our region? We need to, this is x equals 3 and x equals 3. So it is the boundary, also it is a boundary, and it is also the axis of rotation. The question is how to sketch the graph of this parabola. You need, ya shabab, to revise parabolas, how to sketch parabolas. Indeed, this is x minus 1 equals to y squared. So where is the vertex of this parabola? It is at 1 and 0. Am I right? Here it is. It is opens right or left?
Right.
You are right. It will opens to the right. Here it is. Okay. So this is the region that we are going to find the area. Sorry, we will revolve. We will rotate. This is 1. We will rotate this region. But it is here, shabab, not easy to integrate with respect to x. So what you will do, I think we have the graph here. Look, this is the graph. This is y squared. Now what you will do, you will draw a line from the right, from the curve to the right, or until the curve on the. Why I did that? Why I draw this line perpendicular to the axis of rotation? Always the line segment that we will draw, it will be perpendicular to the vertical line here, the axis of rotation in our case. So now we need to find the length because this will be the radius يا شباب. Now this will be r of y. It will be a function of y. It is perpendicular to the y-axis. It will be a function of y. Now, what is the function that we have here? What is y here? What is x here? Sorry. What is x here? X right. It is y squared plus 1. What is x here? So this is, I'm right here. I'm not, this is x that I was talking about. This is x equals to y squared plus 1. What is x here? What is this x? X equals what?
3.
3. Now the distance from here to here, ya shabab, will be the curve on the right minus the curve on the left. So it will be 3 minus y squared plus 1. What it will be? 3 minus y squared minus 1. It will be 3 minus 1. It is 2. 2 minus y squared. Here it is. This is the length of this line. So this will give me r of y, the radius of the disk. If you rotate it, look, this will be the disk radius, the radius of the disk. Now what you will do, ya shabab, if after having r capital of y and your cross section is a disk, then
Get the limits.
integrate, square it, multiply it by, integrate it. So it will be the integral of by, put it out, and here you will have 2 minus y squared all squared dy. You will integrate with respect to y. Now the question is, from y equals what to y equals what? We will integrate from where to where? طبعا, it should be clear from the graph if you sketch the graph correctly. But if it is not clear for you, remember that you will integrate with respect to what? To y. So ask yourself, what is the minimum value here? And you look for y values. What is the minimum y value and what is the maximum y value? To do that, you need to solve these equations. This x equals this and x equals 3. Both them equals to each other. This x equals to that x. Just replace this x here, replace it by 3. Now you will have y squared equals to what? 2. Y equals positive or negative square root of 2. So you will integrate from negative square root of 2 to square root of 2. Is that right? Now you will just replace ry by its value. What we can do here, shabab? Can we make this symbol? Can we use symmetry here?
Even odd.
Yes, this is even. I don't know why he didn't use that. Oh, it is not good. I advise you, ya shabab, if you have a situation like this, use, instead of this, just write it is equals to 2, and here from 0. Why? Because this is even, ya shabab. So this will save your calculations. Instead of substituting from here to here, just substitute from 0 to there and multiply by 2. You will get the same answer, but with the half of the time. So be careful. I think I must change this. It should be clear. Good. Let me, this is also, I need to modify this exercise. Yes. Let's now, shabab, go to the washer method. In the washer method, what will happen? Like this region, look at this region here. We have a region that is bounded by 2 curves, and the axis of rotation here is the x-axis. Now, look at the gap here. We have a gap. There is a gap between, there is a space here between the axis of the rotation and the region. When we rotate, look, when we rotate this region, look what will happen. This is the gap that I was talking about, ya shabab. This space here. So now, because of that, the cross section, if you cut it here now, if you cut it at any place, let me cut it here. I will cut it at this place. Look at the cross section here, ya shabab. It has a hole here. There is a hole inside the cross section. In fact, we will have here what is called a washer. What is the washer? It is like an annular ring, when you have a ring with a hole at the middle. Now, what is good, or what you should notice here, that you will have a disc like this. Previously, we were having a disc like this. Now we will have a disc, but with a hole at the middle. So it is called a washer. We will call it washer. Okay, it is just an annular ring. Now, previously, the radius of this disk, it was R capital. Here it is still, of course, R capital, but we need now to find the area of this disk, because this is space here in the middle. So what we will do in this case, we will calculate the radius of the hole here. We will call it R small, and we will subtract it from R. So when we are going to calculate the area of this, what we will do? We will calculate the area of the whole one, which will be, of course, by R squared. And we will subtract from that the area of the disk here, sorry, the hole here in the middle. So it will be minus by the radius of this. Let's say that the radius of this smaller space here, it is R, the radius is R. So this will be by minus R small. So here it is, ya shabab. I think it is clear for you that this is R capital, the outer, we will call it the outer, this one. The whole one, we will call it the outer. This one, we will call it the inner, the smaller one. And if you remember, we mentioned the cucumber when we were talking about discs. We can here also talk about squash or zucchini. Also, pineapple, you can remember them, imagine them like pineapple. Now, let's do it here with a specific solid. So we have a region here that is going to be rotated about this horizontal line. Then look what will happen. This is what you are going to have if you rotate this region. If you rotate it like this. This is the solid that you will have. Look at the huge washer that we have there. We will call it a washer, but by a washer we mean annular ring like this. Now, what you can notice here that we have here the radius of the smaller space here, the hole, the range of the hole at the middle, we will call it R small n, radius n, which means the inner radius. And the larger one, the radius of the whole disk, we will call it the outer radius. So here by R out, we mean R capital that we used before, and Rn is the smaller r, the inner radius. So in the same way, the R capital will be the distance from the far away graph to the radius of the rotation. This will be R capital. You will do it as you did before for the disk. Here, for the inner radius, the distance will be from the closer graph, the closer curve to the axis of rotation. We will call it R small or Rn as you want. And in this case, the area of this washer will be just the whole area, remove from it the area of the hole. Calculate the whole area. This is the disk, ya shabab. This is the disk as we did before. This one is what is the hole inside the disk. Okay. Let's take an example. I think it will be much clearer. So in that case, the formula, if you have a volume of a region rotated about the x-axis, by using the washer method, it will be just the area of the cross section. We still have talking about the volume as the integration of the holes of the area of the cross section. But in this case, this is the area of the cross section. The area will be just by times the outer radius squared minus inner radius squared. The steps. Also, I make a guideline for you how to sketch, how to find the area by using the washer method. It is just, you will draw a line perpendicular to the same steps. The only change is this. What you can notice, ya shabab, which one is a special case from the another one? Did you notice that one of the methods, the disk method and the washer method, one of them is a special case from the another one? Which one is
washer?
The washer is a special case?
Mm-hmm.
No, I don't agree with you. How? How it is special case?
Because we have two radius.
In the disk method, we have only one radius. So if r of x, the inner, the smaller one is 0, what we'll have? If this is 0, ya shabab, if we don't have a hole, this will be 0. And what is this? This will be the disk method.
So this is the general case.
Yes, the washer is the most general. So the disk method, it is just a special case when we don't have a hole in the solid. So the disk method is a special case from the washer method. Example, the region R, this is the region R is given. This is the region R, enclosed by the curves y equals x, y equals x squared, and it is rotated about the x-axis. Find the volume of the resulting solid. طبعا بما انه الاكسس of rotation, because the axis of rotation here is a horizontal line, we will integrate with respect to x, because we will draw the line perpendicular to the axis of rotation. The cross section will be perpendicular to the axis of rotation. And because of this space here, shabab, because we have a gap look here, we will integrate from 0 to 1. Why from 0 to 1? This is also will answer the question of Nawaf. This is y equals x, y equals x squared. You need to find the intersection points. So you will equate them. It will be x squared minus x equals to 0. X times x minus 1 equals to 0. X equals to 0 and x equals to 1. The same way that we used to find the area, shabab. So now we will integrate from x equals 0 to x equals 1 if you want to integrate with respect to x. Now, because of this, look at the space that we have here. There is a space here. So if you rotate it, this part like this part like this, you will have a hole. You can make it more clear if you just draw how the cross section will look like. This one. This is the one that I draw here. Now focus here, Shabab. I want you to focus here. I will teach you now a very interesting trick, how to find R capital and how to find R small, how to find the outer radius and the inner radius. How to do that? You will do it easily like what? Draw a line from the upper curve to the lower curve. Is that clear? Easy. Now find the distance from the lower here to the axis of rotation, from here to here. What will be the distance from here to here, Shabab? And this will be vertical line. So what is the distance, the length of this line? What is y here? Y here is 0. And what is y here? It is x squared. So it will be what? It will be x squared minus 0. Am I right? This will give you R small, ya shabab. This will give you the inner. Here it is, the inner one. Now, find the distance, forget about this now. Find the distance from here, from the upper point, from the upper graph, the upper curve, to the axis of rotation. The same way, to here. What is it? This will be R capital.
X minus 0.
What is y here? Y here is x. What is y here? Y here is 0. So it will be x. So the inner radius will be x squared, the outer will be R. Here it is, Shabab. This is the outer. And I did this for you with coloring and with lines like this. So the distance from the lower graph to the axis of rotation will be R small. From the upper graph to the axis of rotation will be R capital, will be the outer radius. Now, khalas, when you have R small and R capital, you will just multiply by R capital squared minus R small squared. You will integrate, we said here, with respect to x, and you will integrate from 0 to 1. This will give you the volume. That's it. So here, what is R capital? It will be x squared. This is R capital. Square it, it will be x squared. Square this one, it will be x to the power 4. And you can find this integral very easily. Here we are, ya shabab. This is the area of the cross section. Now integrated from 0 to 1. Is that clear? If it is not clear, I wish that it will be clear when we solve the next exercise or example. Find the volume of the solid obtained by rotating the region in example 5. So we still have the same region. Here, the axis of rotation is the line y equals 2, not y equals 0. Here it was y equals 0. What about if it is y equals 2? Here it is. This is y equals 2. This is the same region, but the axis of rotation now it is y equals 2. What will be the difference, ya shabab? طبعا the volume will be the integral from 0 to 1. We still integrating from 0 to 1. The line is still horizontal, so we will integrate with respect to x because the axis, the line that we will draw will be perpendicular to the axis of rotation. Now, how to find, ya shabab? Now it is by طبعا also it is by r capital minus r capital small, r capital minus r small squared. Okay, the question is, what is r capital of x? What is r small of x? The idea is, I told you, what you will do, you will find the distance from the axis of rotation to the closest graph. So here, the distance, this will be r small, the shorter one, طبعا. This will be, if you have a hole, if you rotate it, you will have a hole like this. This will be r small, and this will be r capital. So this is r small, and the distance from here to here, from here to here, it will be r capital. This will be r capital. I made them with colors, ya shabab. Let me start with r small. R small, it will be the distance from this point to this point. Because here, ya shabab, we have upper. This is the greater one. So it will be the greater one, the bigger minus the smaller. So it will be 2, y here is 2, minus what is y here? Y here is x. So this is r small. To find the r capital, again, it is the distance from here to the lower graph. What is the lower graph? X squared. So it will be 2 minus x squared. Now you will square this and you will bring it as r small. You will square this and you will bring it here as r capital. So easy if you just focus on the method. And this way, by the way that I'm doing here, shabab, is not in your book indeed. In your book, it depends on the sketching the solid and then sketching the washer alone. The idea is the same as I did for you, but you can do that without these two additional graphs. You can do it directly from here. Unfortunately, we couldn't finish. So the cross section here is a washer. This is important. What is the inner radius, which is r of x? What is the outer radius, which is r of x? This is, as I said before here, shabab. And now what you will do, you will by multiplied by the square of the r capital, and this is by multiplied by r small. Integrate them from 0 to 1. Why from 0 to 1? It is clear from the previous step, shabab, from the previous example. We will continue, inshallah. We still have, I think, one example only. Yes, I think one more example, and we are done, because the remaining will be just solved exercises. Okay, shabab, see you tomorrow, inshallah. I'll stop recording. Yes, if you have any question,